Gusev is a crater on the planet Mars and is located at 14.5 degrees south, 175.4 degrees east, -14.5, 175.4. The crater is about 166 kilometers in diameter and formed approximately 3 to 4 billion years ago. It was named after Russian astronomer Matvei Gusev in 1976. A channel system named Ma'adim Vallis drains into it that probably carried liquid water, or water and ice, at some point in Mars' past. The crater appears to be an old crater lakebed, filled with sediments up to 3,000 feet thick. Some exposed outcrops appear to show faint layering, and some researchers also believe that landforms visible in images of the mouth of Ma'adim Vallis where it enters Gusev resemble landforms seen in some terrestrial river deltas. Deltas of this nature can take tens or hundreds of thousands of years to form on Earth, suggesting that the water flows may have lasted for long periods. Orbital images indicate that there may once have been a very large lake near the source of Ma'adim Vallis that could have provided the source of this water. It is not known whether this flow was slow and continuous, punctuated by sporadic large outbursts, or some combination of these patterns. More recently, satellite images showed the trails of dust devils on Gusev's floor. The Spirit rover later photographed dust devils from the ground, and likely owes much of its longevity to dust devils cleaning its solar panels. On January 3, 2004, Gusev was the landing site of the first of NASA's two Mars exploration rovers, named Spirit. It is hoped that the numerous smaller and more recent craters in this region will have exposed sedimentary material from early eras. Although at first the region proved disappointing in its lack of available bedrock for study on the flat lava plains of the crater, Spirit's landing site, it eventually arrived at the Columbia Hills, however, and rocks examined in that region show that the Columbia Hills did have small amounts of briny water interacting with them in ancient times, though nowhere near as much as Meridiani Planum, the landing area for Spirit's twin, Opportunity. However, in 2009, Spirit became stuck in the soil of the region, and in 2010 went offline after a harsh Martian winter. It is also considered a potential landing site for the Mars 2020 rover. Spirit rover's rocks and minerals discoveries on Mars. The rocks on the plains of Gusev are a type of basalt. They contain the minerals olivine, pyroxene, plagioclase, and magnetite, and they look like volcanic basalt as they are fine-grained with irregular holes. Much of the soil on the plains came from the breakdown of the local rocks. Fairly high levels of nickel were found in some soils, probably from meteorites. Analysis shows that the rocks have been slightly altered by tiny amounts of water. Outside coatings and cracks inside the rocks suggest water-deposited minerals, maybe bromine compounds. All the rocks contain a fine coating of dust and one or more harder rinds of material. One type can be brushed off, while another needed to be ground off by the rock abrasion tool. There are a variety of rocks in the Columbia Hills, some of which have been altered by water, but not by very much water. The dust in Gusev crater is the same as dust all around the planet. All the dust was found to be magnetic. Moreover, Spirit found the magnetism was caused by the mineral magnetite, especially magnetite that contained the element titanium. One magnet was able to completely divert all dust, hence all Martian dust is thought to be magnetic. The spectra of the dust was similar to spectra of bright, low thermal inertia regions like Tharsis and Arabia that have been detected by orbiting satellites. A thin layer of dust, maybe less than 1 millimeter thick, covers all surfaces. Something in it contains a small amount of chemically bound water. Plains observations of rocks on the plains show they contain the minerals pyroxene, olivine, plagioclase, and magnetite. These rocks can be classified in different ways. The amounts and types of minerals make the rocks primitive basalts, also called picritic basalts. The rocks are similar to ancient terrestrial rocks called basaltic komatiites. Rocks of the plains also resemble the basaltic shergottites, meteorites which came from Mars. One classification system compares the amount of alkali elements to the amount of silica on a graph. In this system, Gusev plains rocks lie near the junction of basalt, picrobasalt, and tephite. The Irvine Barrager classification calls them basalts. Plains rocks have been very slightly altered, probably by thin films of water because they are softer and contain veins of light-colored material that may be bromine compounds, as well as coatings or rinds. It is thought that small amounts of water may have gotten into cracks, inducing mineralization processes. Coatings on the rocks may have occurred when rocks were buried and interacted with thin films of water and dust. One sign that they were altered was that it was easier to grind these rocks compared to the same types of rocks found on Earth. Columbia Hills. Scientists found a variety of rock types in the Columbia Hills, and they placed them into 6 different categories. The 6 are Clovis, Wishbone, Peace, Watchtower, Backstay, and Independence. They are named after a prominent rock in each group. Their chemical compositions, as measured by APXS, were significantly different from each other. Most importantly, all of the rocks in Columbia Hills show various degrees of alteration due to aqueous fluids. They are enriched in the elements phosphorus, sulfur, chlorine, and bromine, all of which can be carried around in water solutions. The Columbia Hills rocks contain basaltic glass, along with varying amounts of olivine and sulfates. The olivine abundance varies inversely with the amount of sulfates. This is exactly what is expected because water destroys olivine but helps to produce sulfates. The Clovis group is especially interesting because the Mossbauer spectrometer detected goethite in it. Goethite forms only in the presence of water, so its discovery is the first direct evidence of past water in the Columbia Hills' rocks. In addition, the MB spectra of rocks and outcrops displayed a strong decline in olivine presence, although the rocks probably once contained much olivine. Olivine is a marker for the lack of water because it easily decomposes in the presence of water. Sulfate was found, and it needs water to form. Wishstone contained a great deal of plagioclase, some olivine, and anhydrate. Peace rocks showed sulfur and strong evidence for bound water, so hydrated sulfates are suspected. Watchtower class rocks lack olivine, consequently they may have been altered by water. The Independence class showed some signs of clay. Clays require fairly long-term exposure to water to form. One type of soil, called Paso Robles, from the Columbia Hills may be an evaporate deposit because it contains large amounts of sulfur, phosphorus, calcium, and iron. Also, MB found that much of the iron in Paso Robles soil was of the oxidized Fe+++ form, which would happen if water had been present. Towards the middle of the 6-year mission, large amounts of pure silica were found in the soil. The silica could have come from the interaction of soil with acid vapors produced by volcanic activity in the presence of water from water in a hot spring environment. After SPIRIT stopped working, scientists studied old data from the Miniature Thermal Emission Spectrometer, or MINI-TES, and confirmed the presence of large amounts of carbonate-rich rocks, which means that regions of the planet may have once harbored water. The carbonates were discovered in an outcrop of rocks called Comanche. In summary, Spirit found evidence of slight weathering on the plains of Gusev, but no evidence that a lake was there. However, in the Columbia Hills there was clear evidence for a moderate amount of aqueous weathering. The evidence included sulfates and the minerals ago.It and carbonates, which only form in the presence of water. It is believed the Gusev crater may have held a lake long ago, but it has since been covered by igneous materials. All the dust contains a magnetic component which was identified as magnetite with some titanium. Furthermore, the thin coating of dust that covers everything on Mars is the same in all parts of Mars. Features within Gusev Hills. The Columbia Hills is a range of low hills 3 kilometers from Spirit's original landing site. Spirit is currently exploring them. Husband Hill is one of these hills. McCool Hill is the tallest of the Columbia Hills. Larry's Lookout is within Columbia Hills. The Apollo 1 Hills are 3 widely spaced hills 7 to 14 kilometers away from Spirit's landing site. Craters. Bonneville is a 200-meter crater visited by Spirit. Crivets is a smaller crater located within Gusev. Thera is a crater located within Gusev and could be seen from the summit of Husband Hill. Other Sleepy Hollow is a shallow depression near Spirit's landing site. Adirondack is the name of the first rock visited by Spirit. Home plate is a layered geological feature recently studied by Spirit. In popular culture, Gusev crater is the landing site of the Mars Consortium mission in Gregory Benford's 1999 novel The Martian Race. The setting of the Doctor Who episode, The Waters of Mars, is Bowie Base 1 in Gusev crater. Gusev crater is featured in the science fiction TV series Defying Gravity as the location of the Alpha extraterrestrial signal central to the plot. It was also the landing location of the failed Mars mission that took place in 2042.